FastMCP3 implements a relevance-based tool discovery mechanism through the BM25 search transform, which ranks available tools by their semantic alignment with natural language queries. This probabilistic retrieval system replaces exhaustive tool enumeration with on-demand discovery, optimizing token efficiency while preserving full tool accessibility. The upcoming code demonstrates how a client invokes the synthetic search tools utility, passing a natural language query that the BM25 algorithm processes against an in-memory index of tool metadata. The transform will return ranked results, with delete record prioritized over search database based on term frequency and inverse document frequency calculations. Result equals await client. Call tools search tools. Query tools for deleting things from the database. Hash returns delete record ranked first, search database second. This code demonstrates the BM25 search transform in action, where the client queries for tools using natural language. The BM25 search transform replaces the full tool catalog with a search interface, exposing only two synthetic tools: search tools and call tool. When the client calls search tools with a query like tools for deleting things from the database, the transform applies the BM25 OCopy algorithm to rank tools by relevance, scoring based on term frequency and document rarity across tool names, descriptions, and parameter metadata. The search returns results in the same JSON format as list tools, including full schemas, so the LLM can immediately construct valid calls. Here, delete record ranks first because its description and parameters align closely with the query, while search database appears second due to partial relevance. This approach is ideal for natural language queries, as it handles partial matches and synonyms better than regex-based filtering. The transform builds an in-memory index lazily on first use and rebuilds it when the tool catalog changes, ensuring results stay current without manual intervention. The trade-off is that BM25 has higher overhead than regex search due to indexing and scoring, but it provides more nuanced relevance ranking. This is particularly valuable in large tool catalogs where precise filtering by pattern is impractical. The transform respects the full authorization pipeline, so tools hidden by visibility rules or middleware won't appear in results, maintaining consistency with list tools' behavior. Let's break it down line by line. Result equals await client. Call tools search tools. Calls the search tools method on the client object asynchronously using await, passing an empty dictionary as the argument. The result of this asynchronous operation is assigned to the variable named result. Query tools for deleting things from the database. Defines a query string with the value tools for deleting things from the database that appears to be searching for database deletion utilities or methods. FastMCP3's BM25 search transform replaces exhaustive tool enumeration with relevance-based discovery, using natural language queries to surface the most appropriate tools dynamically. The client's call to search tools with a query like tools for deleting things from the database triggers the BM25 algorithm, which scores tools based on term frequency and inverse document frequency across their metadata. This probabilistic ranking ensures delete record appears first due to its strong semantic alignment, while search database follows as a partial match. The transform maintains consistency with list tools by respecting authorization pipelines and returning full tool schemas, enabling immediate LLM-driven execution. While BM25 introduces indexing overhead compared to regex, its nuanced relevance handling excels in large catalogs where pattern matching falls short. The lazy index construction and automatic rebuilds keep results current without manual intervention, balancing efficiency with precision.
The database fetches its own tools, then returns them like a magician pulling rabbits from its own hat.